this projector on?
He's the founder and CTO of White Hat Security, and will be talking to us about business logic flaws in web applications. So, welcome.
Thank you. Afternoon. Thank you, guys. Appreciate it. Thanks all for coming. I got pulled in last minute. Chris invited me to speak, so I don't know who you guys were expecting, but hopefully there is a. Am I causing that? Thank you. Appreciate it. So I'm going to talk about business logic flaws. Obviously, these are things in web applications. I'm not going to cover too much about my background because I already know me, and yeah. So web application security. Most of us, when we're talking about in the conference here, which a lot of the vulnerabilities and botnets as a result have to do with the well-known vulnerabilities on the bottom of the layer there. So some researcher finds a vulnerability in Windows, Linux, Apache, whatever the case may be. They get disclosed to the vendor responds with a patch, and we get big piles of signatures that network vulnerability scanners love to find for us with products like Nessus, Encircle, Qualys, and pick your network scanner, and they go after the well-known web application the well-known application vulnerabilities or in whatever kinds of software. I don't deal with any of those. I deal with custom web application software, the software that companies write, maybe the companies that you work for write and put on top of their web servers. Software that's unique to that organization, and hence all their bugs are their own, and all the vulnerabilities are more or less one-offs. And when you look at these custom web application vulnerabilities, they come in two broad types. One is the technical vulnerabilities. The other one is the business logic flaws. And they're very important distinctions because usually the technical vulnerabilities we can find through purely automated means, and the business logic flaws we can't. So when you look at the classification of web application vulnerabilities, this is the classification I like to use, the WAS threat classification, the 24 known classes of attack. These are the technical vulnerabilities. Words like cross-site scripting, SQL injection, LDAP injection, command injection, and so forth. These are the ones you can usually find through purely automated means. That's why we see them littered all over full disclosure and bug track and things like that, because we can find them easily and they're very, very prevalent. The ones we can't find, and the ones we don't talk about much, I don't know exactly why yet, but that's why we bring up the topic now, are these business logic flaws. Business logic flaws are where we can do very interesting things with a web application, jump into other users' accounts, rotate numbers to get access to data that's not our own. They're usually unique to the website, unique to the web application, and as a result, there's really no known signatures for how to isolate them. So most of this presentation will be made up of stories on real-world types of attacks that we've seen in the wild, and everything that we're going to talk about here we actually see on most of the web applications my company finds when we look at normal websites. So what is it about these business logic flaws that makes them so difficult to deal with? First of all, we talk a lot about security in the SDLC, that developers or QA people should be finding flaws in the code, but business logic flaws will be often missed because QA, their job is to test to make sure the software does what it's supposed to do, not what it can be made to do. It's diametrically opposed. Does the bank account allow you to wire transfer money from your account to another? But nobody ever really tests it to see if you can force it to wire transfer money out of somebody else's account into your own. So just to reiterate these points here, scanners don't find them, IDS doesn't detect them, and web application firewalls, for the most part, can't defend against them. We have to find them, usually by people that are specifically looking for these issues. So, we're going to go through a bunch of stories. Feel free to ask questions whenever you like. Try not to test these on sites that are not your own or you don't have express written permission. So the first one that we're going to cover is winning an online auction. Now, I'm not going to reveal the online auction's name, but there's only one in the world. I didn't know I used to work for Yahoo way back when, and the one you're thinking of is probably not it that this applies to. Yahoo used to have an auction way back when. This was valid in that particular case. So when you're on an online auction site, we're going to cover two discrete systems. We're going to cover this, in this particular example, is what we call abusive functionality. When you try to log into an account, if you get your password wrong a few times, you might get locked out of your account. The standard anti-brute force mechanisms to prevent brute forcing. Fail 5, 7 times, 10 times, 12 times, whatever, you lock the account. Let's say, for our discussions here, that system works perfectly in and of itself. You go to the other end of the system, another discrete component of the website, the bidding process. You find an item that you like, could be a nice looking power book, whatever you so choose. You select the item, you put your bid price in, you hit go, or whatever the case may be, and then it asks you to verify your password to make sure it is what you wanted to bid for. So you type in your password again and your bid goes in. Now, if you're like me, you want to get an edge on the competition. So what happens is, should somebody decide to bid against you, they will bid just over the top of you, and you'll see that you've lost the top bid and who bid against you. You take their username, you wander back over to the login screen, you put their username in, you purposely fail their account a few times until it locks. Then you outbid them. Next time they go to bid, they're going to have a really difficult time outbidding you. So it doesn't guarantee you a great price on the item, but it does increase your odds because now you're limiting your competition. And this works, used to work very, very well. And there are solutions to defend against this that you might have noticed on the more prevalent online auction systems out there. I forgot to change slides, so I will skip past this one. So what are some of the solutions we can talk about here? Don't display usernames on the website if at all possible. Better to use profile names, so that prevents the bad guy from knowing who to log in as. We can use CAPTCHA systems, which everybody knows and loves, instead of an account lockout explicitly. So should the user still want to make that bid, they can type in the crazy, everybody knows what a CAPTCHA here is, right? Stupid letters in an image. I'm sorry about that, we developed that at Yahoo. Carnegie Mellon was mostly their fault. So we can put CAPTCHA systems in place, and also we can allow sellers to put minimum bid prices in there. So should the bad guy get too good of a buy price, they can deny the transaction. So these are some of the solutions here. But you quickly see that we had two discrete systems that were perfectly secure in and of themselves. You put them together, you have an insecure scenario. Now, most humans won't know to look for that, let alone an automated technology, whether it's finding of the vuln or defending of the vuln. So they get very esoteric here, but once you see the trick, it becomes very easy to use it for interesting activities. So let's move on to the next one here. Interactive television, this is one of my personal favorites here because one of my favorite movies ever is Hackers, and this is kind of a real-world example of this, sort of. So this is an example of insufficient process validation, we call it. There was a television news station south of us in North Carolina, Cable News 14, and this particular site had a service. This service allowed people to register on the site and submit news to the site in case of severe weather. If the school closed or if a business closed, they would push it to this website, and it would show up on TV in the crawl space, like on the Fox News alerts and things like that, right? So now the news stations got real smart, right? They had when the bulletins came in, they sanity checked it, make sure it was G-rated for TV, and then they allowed it to air. And what people could also do is that they could edit. So should the school reopen, should the business reopen, they can edit their entry. The problem is that the station managers didn't have a process in place to revalidate the edit. So what somebody found was that they could enter something completely valid and then change the message that was showing up in the crawl space on the TV. If you look real closely, that's Haxford Computer Services on the right and Pont Industries on the left. What was interesting is that these are the only two screenshots that I'm able to publicly display in a setting like this because there are only two that were G-rated. Yes. I came from Orlando, they probably would. So, so the other part was that the particular person that found this, I believe was a college student who posted it to a college message board, and many hundreds of people had their fun with this particular system. I'm sure the FCC did not take kindly. So the solutions to this one is obvious, is they had to have a re-sanitization process in place, just like on the first time, but with the edits as well. But again, it shows the point is, how do we know what this feature does? How do we know when it does it, it's a bad thing from a purely automated standpoint? It's just another one of those things that you look at the system, if you know the design criteria, you can start having fun with it. Let's move on to number 3. Seeing Steve Jobs up close, another cool one, especially since I am a Mac user. This is a great example of information linkage, but in a unique kind of twist. Not at this year's, but the year before at the Macworld conference in 2000, not this last Macworld, but the one before, you could register to be what they call as a VIP. If you wanted to see Steve Jobs' keynote, you could pay $1,700, or if you have the special VIP code, if in case you're a press or some other important person, you can put in this code and get one of these platinum badges that would get you into the keynote, get a chance to see Steve Jobs say one more thing and all that other kind of cool stuff. Now, if you view the source of the registration page, inside the source, there was a bunch of these MD5 hash signatures in the source of the page. Now, the way this process worked is, when you put in a priority code, it would use JavaScript to hash the digest on the client and compare it against all the valid ones on the client. If it was a match, then it would send it to the server for extra validation on the server, right? So a friend of mine who lives in San Francisco, works for PG&E, decides that he wants to get into the expo. He says, okay, well, the priority codes are 5 characters in length, digits and uppercase characters, creates a 10-line C program, he probably did it overkill, and cracked to found the priority code. He used it, registered himself for a platinum pass, and got into the conference. After he came out of the conference, he told the Macworld Expo organizers what he had done, and they said, thank you very much for letting us know, we will take care of the issue. They did some forensics on it and found out that he wasn't the only one that found it, just the only one that told them. So what was interesting, and I didn't get a chance to update the slides, he actually did the exact same hack this year. They said thank you again, and he did too. Now you know how. So you'll hear a lot of best practices that say don't do client-side validation. I personally don't find anything wrong with it. You can do client-side validation to make sure the user types in their password correctly, their first name has the right character set in general, but you don't want to depend upon it. Of course, you always want to do the extra validation on the server side. The reason you like to do it on the client because it increases responsiveness, reduces load on the system. But the trouble in this case, when you're doing client-side validation, you're actually putting the secrets from your system on the client. So in this case, client-side validation wasn't a particularly good thing. Better just to bite the bullet on the performance hit and do it on the server rather than giving out free VIP passes. All right, let's make some money. All right, day trading contest for $1 million. This I found particularly interesting. Every web hacker in the world kicked themselves for not having found out about this contest prior to. So I want to say 2 years ago, CNBC hosted this day trading challenge, right? They invited everybody to sign up for this game, and whoever could, they set up 10 one-week challenges. And if you won one of the one-week challenges, meaning if you made the most funny money by trading stocks, you win $10,000. And if you won, you get a chance to go into the finals to play for $1 million. So a lot of money on the line. A lot of people are excited about it. 375,000 people signed up, so not an insignificant number. Now, this system, when they, again, it's funny money. When they set up stock trading on the system, it was very easy. You pick the stocks that you wanted to buy. And the bid price and how many shares you wanted, and you hit go. Had a secondary process that said, okay, this is your order. Would you like to execute this trade? Step number 2, yes or no, drop out or execute, and that's how the 2-step process worked. Now, in the following days, very quickly during, I believe it was the second or third week, a few users were making insanely high gains, like unbelievably good picks. Right, these people should not have been playing this game if they're doing this on the level. So what was happening was that what was found was that they would find stocks that were set to post earnings just after that day's trading, and they would load those stocks, those ticker symbols, into their trade, press go on phase 1, but not execute the trade on phase 2. They would just let it hold there because it's stored in the session. After the trading hours closed, they would watch an after-hours trading because the earnings and the reports would come out how the stock would move, and if the stock went up, they would hit buy and get the previous day's buy price. If they didn't like the way the stock moved, they would just ditch out and not use it. Now, had this been just a silly game with no money on the line, would have been no big deal. But remember, they're playing for $10,000 and if not $1 million, so people were pissed, right? You know, people were spending a lot of time and a lot of research doing this, and people were running away from the game. So I should have had a screenshot from CNBC, but they closed down the website, canceled the contest, right? Everybody was really upset. They launched this massive investigation. Lawsuits were like getting threatened and things like that. And they kicked a bunch of people out, and finally they gave away the $1 million, but nobody was entirely convinced that she did it on the level either. So, entirely possible. We have found very similar attacks on actual stock trading websites. We have checks made out to WH Test. So what are some of the solutions here? There's all different kinds of solutions that would have made this much more difficult, if not impossible. When executing a trade, you might want to check that the market is not closed at the time of the trade or deny it, limit the session timeout, or even trade on the actual stock price rather than the one that was originally set up in the session. Not too difficult to set up, but you can kind of see these types of things aren't overly complicated once the flaw has been pointed out. Any questions so far? Okay, it's easy stuff, just fun. All right, online poker, gigantic phenomenon. Everybody loves poker. Everybody loves Texas Hold'em and all sorts of online games. Whether or not they are illegal, you'll find online games, poker style, even blackjack, and also in games. You'll find in massive multiplayer games, you'll find variants of poker. And poker games get extremely complicated as far as how they work, what cards are shown when. And in this particular case, we're going to talk a little bit about blackjack. And blackjack is one that's particularly gameable on the right system. Everybody here is probably familiar with blackjack. Game of 21, you dealt 2 cards face down. You try to get as close as you can to 21 without going over, and better than the dealer. Again, the logic flow in these games, especially poker, you have to get it perfect, you have to get it exact, and all these different logic trees take different amounts of time to execute depending on what's going on. So there was a particular case, and this was on Paradise Poker. There was a particular case, and this one was on Paradise Poker, where the dealer found out, the player found out. So if you're familiar with blackjack, if the dealer's card is face up, if the dealer's face-up card is an ace, the player should be offered insurance as a way to hedge their bet in case the dealer has blackjack. More familiar to everybody here. Well, what this particular player noticed on Paradise Poker is that it would take a different amount of time for the game to offer the player insurance, depending on whether or not the dealer had had blackjack or not. So if the dealer had blackjack, he would instantly buy insurance. If they didn't, they wouldn't. And they would get a little bit of edge on the house in these cases and actually made a lot of money on Paradise Poker just by noticing an online digital poker tell. You can actually tell the state of the game based upon the time at which it would take to respond. And if you actually watch closely on a lot of the online games, these attacks are all over the place. You can actually tell the state of the game based upon the execution. You can actually exaggerate these types of timing variances if you just do the right thing with the right tricks. I play a lot of Texas Hold'em on the Xbox 360, and these things are there as well. So I've not found any research that I'm aware of that explicitly tells you how to handle these timing-based issues. Code takes a certain amount of time to execute. You can pad certain areas, you can add timing to certain areas to try to smooth it out, you can add random bits of time, but these are very, very difficult, timing attacks are very, very difficult to deal with, especially on remote connections like over the internet. If anybody has better ideas, I am all ears. So the next one is I'm going to take you through a business case, one that we experienced at Yahoo many, many years ago when developing these password recovery systems. And password recovery systems, every site has them. Many get them wrong, and they can get incredibly complicated. So what's the rationale behind having an automated password recovery system. The rationale is really simple, actually. We want to reduce the cost of customer support, people calling in that have forgotten their password, lost their password, or whatever. So we want to make some kind of automated channel using technology to reduce those costs. So usually that process is driven by the business owners without a really good idea of the security implications. So you'll see all different kinds of ways on how to recover your password. So let me look down here and see where I'm at. So one of the big ones is that people will ask for, what systems will require are secret questions and answers. Everybody loves those things, right? So the business owner, in this case, said, well, we'll just ask people what their favorite color is. No problem, right? If they know the secret color, they enter their email address, we'll ask them for their secret color, and if they get it right, we'll allow them to reset their password. Except the problem is very quickly that users only have one of 7 or 8 secret colors, so that's easy to brute force, so that really doesn't work too well. So that's easy to defeat. So they move on to the next step. Let's make this more complicated. Let's increase the entropy. And in addition to the secret color, their favorite color, I should say, let's track their date of birth. That should be cool. Okay, we got, many, many dates of birth, possibly. It's 12 times 31 times however many years we want to try. And if you get both correct, then we can allow them to set their password. I'm sorry? Is that how they do it?
Well, no, you usually get their month and their day on Facebook.
All right. So now, the problem with date of birth is that what we found in our particular system, date of birth, the entropy isn't all that large. It's if you take the average person online, it's not that many years, and it's only about 16,000 or so guesses to actually get their correct date of birth. And not only have you reset their password, you've actually got their date of birth, which has interesting privacy implications as well. So that didn't work so well. So we actually had to add a CAPTCHA system to that as well to prevent people from brute forcing. But even still, the entropy wasn't all that large because date of birth isn't exactly a private thing since people are sending each other birthday cards and things like that. So they said, okay, let's make this a little bit more difficult since that process isn't working and it's actually adding more customer support because people's accounts are getting hacked. Okay, let's try city of birth this time because surely you cannot get the person's city of birth, date of birth, and favorite color. Okay, that works pretty good in the US, cumbersome for the user, but it works pretty good in the US, except when you start rolling it out to different geographic locations, one of which we ran into was Mexico. According to Wikipedia, what does it say? 30% of the population come from one of 5 urban areas. Okay, no problem. That other 70% should be a lot of different places, so that's okay, except that 30% is actually 90% of the Mexico users on Yahoo. And it was actually quite worse than that, since about 90% of our Mexico users were actually from Mexico City. So your entropy that would look great in the US didn't work at all when we rolled it out to Latin America, and the same thing happened in Korea and China and every place else we tried it outside of the US. So that didn't work. Okay, so scrap that idea. Let's move into a completely different way. Let's try email addresses. We'll email them a link to reset their password. All right, how's this work? If you notice on the bottom there, this is the first attempt by the developers. They click on a link that says password reset, and you just put in the username, the email address to the user that you wanted to email the password reset form to. That didn't work so well. Didn't work at all. All right, so let's get a little bit smarter about this. We can't make that ID predictable like an email address, so we're going to use big, long numbers instead. We're going to make a great session identifier. Huge numbers. No one can ever guess these numbers. So what the bad guys end up doing, if you guys are all snickering, then you can kind of see it right away. They would start resetting their own passwords on their own accounts to see where the counter was, and then start entering a password reset process for another account they wanted to go after and increment up a little bit until they could reset that particular account, or they just decrement down to get people in the amount of time that would take. They would just get to the link and the password reset before the legitimate user would. You lose a lot of accounts that way. And now the interesting thing was we learned in that particular system, because when a particular user on that system gets hacked, you're not going to get any money, you're not going to get any value out of the system. I mean, we're in a bank, right? Webmail provider at best. But what we found was that just like domain names, really short, really cool domain names actually have a lot of value, right? On that system as well. If you had john@yahoo.com, that was really valuable. Same with profane accounts and things like that. So going after these accounts actually gave them real world value just by having that name. And they used to hoard them like they would hoard domain names. So I thought that was pretty interesting. So the next step is, okay, we're going to create, I passed this slide, I have a tendency to do that. So what can we learn from this? So the best way that we've found to deal with password recovery systems is to keep them simple. You don't want people to guess the link. I mean, the best way just to keep it simple, you risk the sniffing aspect, but putting your email address will send you a password reset link. Make sure it's unpredictable from a session ID. Click it, reset the user's password, and go on about your business. The whole business with secret questions and answers gets really difficult to manage. My online bank wants to know the name of my kindergarten teacher. I just kind of treat that as another password, and I don't like it at all. And then just more passwords for people to remember. But I imagine a lot of normal users are putting in the name of their kindergarten teacher or whatever the crazy question is, and just giving a bank more sensitive information about you that they really don't need. All right, let's go back to making money. Let's make millions by trading on semi-public information. This is a combo attack with predictable resource location, also known as forced browsing, and sufficient authorization. So in this case, there was a very popular site that's still around today. It's called Business Wire. Business Wire has two different types of customers. One is the companies that post press releases to Business Wire, and they pay for this ability to get wide distribution. And they also can put embargo dates on these files to make sure nobody knows about them. They don't get released prior to this embargo date because it might move stock. They also have other subscribers, media, press, analysts, whatever, that subscribe to this service to get quick access to press releases through a centralized source. Now, what happened in the case of Business Wire, again, this is a real case. Business Wire was actually, when a press release came in, they would post the press release in a URL format that had a date stamp on it, and they would ID the name of the file on the very end to keep them all unique across the system. They had security built in around this, okay? It wasn't linked in to the site, and it would actually check to make sure that you were actually logged into the system. What it wouldn't do is wouldn't authorize you to see if you were able to see that file in case the embargo date had not yet been reached. Now, some very clever Estonian financial firm found this out. Excuse me. They found they can access these press releases prior to their general release date, only if they were logged in. So they decided to take this data, run some crawling or some spidering on it, find these press releases, and trade on this data. They actually had made over $8 million before the SEC had caught on, and the SEC froze their accounts and launched an investigation. I kind of lost track of the story at that point because no more information was made available. I think the investigation just died and they kept the money. Don't know for a fact, but I couldn't find anything else on it. But what I did find was that actually, let me pose this one to the audience because it's more fun that way. Is the data that these guys accessed, given it's on a publicly accessible web server, is this data public if it's on a publicly facing web server? It is public, okay, that's one belief. Is it hacking what they did? Is it hacking to guess files and directories on a file server? So not everybody agrees. You believe it is, somebody says no. No, let's say legally. I know we're not lawyers, so let's just,
Well, legally it's probably not, but I think you can look at something if you put it out.
It's clearly not
So now our company has found press releases and other strange types of data like this all over web servers by guessing the name, no password required. It just wasn't linked in. The second question is what they did illegal under what we would consider insider trading laws? Legal, illegal? Most people thought it was illegal. Until just recently, there was a different case where I forget the exact details. I haven't had a chance to update the slides, but a Ukrainian hacker broke into a US company, got access to early information, probably press releases, and traded on the data and made $500,000. The case was brought before an SEC judge who declared that it was, in fact, legal because he was not an insider. The insider trading laws did not apply to an outsider. He was allowed to keep the money. I'm sorry? That was the point. The judge actually said that what he did was in fact illegal. It was not a brute force. It was not a URL rotation hack, right? He actually broke into the company, committed computer fraud. Unlikely he'll get prosecuted because he is a Ukrainian national, right? However, imagine now we have all these publicly facing web servers with data all over it, and you can trade on this data completely legally, provided you're not an officer of the company. It's a very interesting world now. Everybody got real quiet, like, I'm not going to go run home and do this, right? It could be. They weren't investigated.
Quick question, sorry, no meaning to interrupt.
That's okay.
When you say that you're creating, when you say that you're creating, how do they prosecute them? Is this some sort of, green trial that goes on? Defendant is not.
I wish.
You have to serve people like that.
I think, I tell you right now, I don't know the specifics on how that was brought forth, but I believe there's a holdup in the money, like this particular person had a broker in the US that filed the trade, and they froze the money, so I think it went to that way. So they released the funds. Like he made $500,000, which I guess goes pretty far in the Ukraine. So, obviously in this business wire case, they probably wanted to add a little bit of authorization and probably not make their URL so predictable. They want to make sure the embargo date has lifted. So, some easy way to make money. This next example here, I described for you because I wanted to convey the amount of time people have on their hands to do the most inane things for who knows what reason. All right, so Yahoo Games has a chess ladder. The way this chess ladder works is you play games against other opponents, and the more you win, the more you rise up the ranks. And there's a lot of people that want to be number one or in the top 10 on the ranks. And so the way the rules of the game work, you have to play people around your game level to get points and move up the ranks. If you don't play against people routinely at around or above your rank, you will actually decrease in rank, which makes for a very exploitable system, actually. So what would happen is that we would get launched with thousands and thousands of botted games on, accounts that would all play within their block. They would all play win and lose against their block and slowly inch their block up the ladder. The interesting side effects of this is that the real legitimate users that are just above the block would have to play above their rank, which usually they would lose because anybody around or lower, they couldn't get a game in the botted block. They just wouldn't play them, and they would slowly fall down the ladder. And this big blob of accounts would slowly move up into the top 5, top or so. And the top players, since there's no one above them, have to play a game with those below them, but they don't exist. So they would automatically fall off the ladder, and the big blob of the guys would own the ladder. Now, at first blush, I would say, who cares? It's Yahoo Games, right? This doesn't cost you anything. This is free. Get over it, right? But users were pissed. Users would call and call and call and yell and scream, and it would cost a lot of money in call support time, right next to the people that had to get that forgot their passwords or had their accounts hijacked. Now, it was kind of an interesting phenomena. So we tried all sorts of things to get this to solve this particular problem. We tried resetting the ladder every so often. we should reset all the rankings to 0 to discourage them from doing this. This only helped them. They would actually spend all day, all night, waiting for that moment where we reset the boards and launch on and get the top spots immediately. The normal users were not as dedicated. So we would try captchas on the system. That only caused user revolt. Users hated captchas every bit as much as we did. And we ended up just leaving it because we had lack of options at that point. But we could actually see when people would wake up and sleep on Yahoo Games, because I swear there were cultural wars. Like the Eastern Europeans would try to play and outplay the Koreans and the Chinese on chess, right? It was like a sense of national pride, to be #1 on Yahoo chess, right? So life as a web security person for a portal. All right, let's make some more money.
Have you tried analyzing the behavior of these people and figuring out whether it's a bot?
Oh, they were definitely using bots, very sophisticated tools. These guys were programmers.
But did you try to analyze the log files, for example, to see the behaviors?
Our log files? They would just be playing. It would just be a chess game. It would just.
When they log in, right? So if they start a game, you know when it starts, you know the usernames, so you might be able to find the cluster of people that play with each other all the time. Then you see the others that try to mash.
Oh yeah, we absolutely tried kicking them off, banning their accounts and things like that, but they would just generate thousands and thousands of more. I mean, the accounts were free, right? I mean, it was just this insane problem, and it was a 24-hour game because they had bots, so they didn't have to sleep. Hackers would go to sleep eventually. The humans, actually you can notice it. So the US hackers would go to sleep at probably midnight, 2 a.m. Then the Eastern Europeans would start their circle, and then they would go to sleep, and then you see, more East Asia, the Japanese, the Chinese, the Koreans, they would wake up and start hacking, and the cycle would then repeat itself. So I did sleep for about 2 years.
How many clusters of players did you have? Was there one American group, one Korean group?
It was-
Were just all doing this shit?
They seemed to cluster country by country, and then cross-pollinate and infiltrate each other's groups because they wanted each other's tools.
So wouldn't it be better just to leave them alone and keep them off of those systems when they cause damage?
Well, so the way I like to put it is, at the time, Yahoo had 180 million active users. We figured 1% of our user base was malicious because it was consistent with Visa, eBay, Amazon. So that was 1.8 million bad guys all the time. There was, when I say bad guys, it's hackers, credit card fraudsters, the guys that screw around with the games, pornographers, spammers. They made me stay up late, so they're all bad guys to me. So there was plenty of bad guys to go around on every single system. One business logic flaw we found that is not up there was on, you guys remember Yahoo Points? You generate Yahoo Points, right? So Yahoo Stores had a promotion where if a user would buy something on one of the stores, they would get Yahoo Points, which are convertible for prizes. So one clever person decided to start up a store and buy from himself, and made a lot of points, and then traded in for Yahoo Auctions gift certificates, and then auctioned those off, and made a great chunk of change. And you might ask how we found him. He had the most points. I'll tell you, we were clever guys. All right, so let's rob a bank. Very easy stuff. Banks are actually what we find one of the easier targets because most of the code is not battlefield tested. A retail website happens to be more secure because most of the internet is banging on these systems to find credit card numbers, and most of the functionality is exposed without needing a username and password. Not so with a bank. Once you have a username and password in a bank, which requires opening up a bank account, most of the functionality is not tested by the general masses. So you get greenfield territory to do all sorts of cool stuff. Now, in the case of most small and mid-tier banks, they're actually run most of the time on ASPs, application service providers, who write banking software, and then many banks use this software, and it's all in one centralized place. So rather than targeting a big bank who does all themselves, it's much more compelling to hack an ASP, which gives you access to hundreds, if not thousands of banks. You make one hack, and you're across the entire system. This one particular ASP had the way their system was architected had, this URL here had 3 different identifiers: a client ID, a bank ID, and account ID. The client ID was the actual banking customer, and each banking customer was given a client ID. Now, if you had multiple financial applications, those are all uniquely ID'd, so you can have multiple financial applications on one ASP. And then tied to each bank ID were their account IDs, the end customer, who had, stock trading, their bank account, checking account, credit card account, or whatever the case may be. So we were tasked to check the security of this particular system. Now, most of the time when we're doing work for financial institutions that are ASP hosted, our customer is the bank, and the bank then turns around our data to the ASP, but we don't work directly for the ASP. However, they do have to give us authorization. So when we start testing this particular system I'm talking about here, we decided, okay, let's first change the account ID to check their authorization to see if it works. So in this particular system, we changed the account ID, and in big bold letters it says, oh wait, you can't do that. Account X belongs to bank Y. Okay, well, that sucks for us, I guess. So we change the account ID to what we had before. We change the bank Y, and we get another gigantic, big, bold red error message. Wait a minute, if you want to use that account ID and that bank ID, that belongs to client ID Z. Oh, okay, cool. Let's try that. So it was actually leading us down the path of a hack. It was actually helping us. It was, it's a very intuitive system. So we plug in that client ID, and all of a sudden we're able to jump into just about any, well, I would say we didn't try them all, but we could jump into any account on any bank that we wanted. Big disaster. In fact, we found out later that this system had an authentication check, so to even access this, you had to be authenticated. But as a general principle of the system, it had no authorization in it at all. Like they had missed that if statement across the entirety of the application. They didn't check to see what you wanted to do, if you were authorized to do it or not. So we described the problem and how best to fix it, like you're going to have to rewrite the whole thing to the developers. And I guess, so how they fixed it initially was, they said, okay, we had fixed this, and they had done this within like 48 hours, right? Because it was like a high priority issue, or how did they do that, right? We're going to learn something, right, about authorization. I don't know how you fix this stuff so fast. And then one of our really brilliant engineers decides to view source. They had commented out the error message in HTML. So anybody with view source could still do the same hack. Granted, it wasn't in big, bold red letters anymore, but just the same. That system actually couldn't get fixed because it was going to take a rewrite of the application and stayed vulnerable for quite some time. Apparently, it's very difficult to swap your banking ASP service provider.
Is a big bank or much small banks?
I would say many, many, many medium-sized banks, probably 600 medium-sized banks, if I can recall correctly.
Would any
Regional banks, I should probably say.
regional banks?
Yeah. So credit unions are notorious for on ASP systems as well. What we also found is that once a regional bank or a regional credit union is a customer of the ASP is not incentivized to check or to update the security of their ASP because they already got your money and you can't move. We find vulns. What I don't know in this case. What I can tell you is there have been a number of cases where the vulns we have found have been exploited, which actually, interestingly enough, helps the security guy more than you might think, because he actually kind of did his job. I told you there was a vulnerability, you didn't fix it, and look, we got owned, and all of a sudden he gets like a ton of budget. So, Adam Shostak had that great post on like security incidents might actually be good for you. We've actually noticed the same thing anecdotally. Any other questions? Okay. So solutions here, again, are pretty straightforward. You can, make sure you don't put useful error messages to the bad guy on the output. Definitely scrub those. Great for, QA debug purposes, but you definitely want to scrub them before you push them to production. And you want to definitely make sure that the user is authorized to do the action before you allow them. Another common, I won't say common, but it happens from time to time on another little hack that no, don't try it. is something we call a reverse wire transfer. Depending on how the system's architected, it might have some very interesting math in how you do a wire transfer. In a normal case, if you wanted to transfer $10,000 from account A to account B, generally the formulas will be the new account A value is A minus the value you want to transfer, $10,000, and B, you want to add $10,000 to the account you want to transfer money to. But you can't start playing around with reverse numbers and screw up the formulas. You can actually transfer a negative 10,000 number and start siphoning money from somebody else's account. You can subtract a negative from your account and make 10 grand and subtract it from account B, and this works brilliantly, especially on those ASP service providers, because they don't expect you to put a negative value. Makes the auditors go crazy. So there are many, many more of these cases in business logic flaws in this book. It's actually a great book for, especially chapter 11 has more and more cases of business logic flaws. Again, these are incidents that we find I just pulled the ones off the web and some of the ones that we found, but we find these day in and day out every single day in our work. And so to go back to where we began, what do we do about these things? This is kind of like the next evolution. It's sooner or later we're going to figure out how to deal with cross-site scripting, SQL injection, command injection, all the other ones that we can find with scanners. But these are the ones that are really going to plague us. While they're not as voluminous in numbers, their severity is quite high. The QA process, probably the best place to find this rather than by the time it's pushed. But the problem is that these guys usually, again, test for the site the way it's supposed to function, not the way it can be made to function. So there is a theory out there that we might be able to develop abuse cases for these things to test the site in ways that it can be abused, but even that's somewhat limited since we might not be creative enough to create these abuse cases. But at the end of the day, though, we're still going to need experienced experts and people like that that are familiar with these types of hacks, checking these systems, because it's either the good guys that do it or the bad guys are going to do it. The bad guys don't charge, though, so maybe. All right, I've got through all of it. Questions? Yeah.
I'll save the more problematic question for offline, but you just said that business logic flaws are less frequent, you think, than SQL injection cross-site scripting. But if we don't have automated tools that are looking for that stuff, and you don't necessarily have a lot of researchers who are looking for that stuff, most cross-site scripting, most SQL injection is really low-hanging fruit, fairly easy, fairly quick to find. So do you have anything to sort of back up that assertion? Is it just
That statistically they're lower? Outside of my statistics, no. We do our best to find every single vulnerability we possibly can on a website, and statistically it's lower. We rate SQL injection obviously pretty high, cross-site scripting a little lower, but almost always the business logic flaws here, this is like game over. I mean, were any one of these particularly hard? I mean, these are low-hanging fruit. I mean, scanners find low-hanging fruit, yeah, they just don't find all of it. I mean, I didn't go through the ones where you just rotate a number to URL, you landed in somebody else's account. I didn't go over those because it wouldn't make for much of a story, But so how are we going to deal with these things? It's going to be tough, but the bad guys don't have to go out. They don't have to be as creative as this. SQL injection is still in mass. What's funny? What I found is that the bad guys actually don't use scanners. The good guys use scanners. Why is this? Good guys use scanners because they have to find as many vulnerabilities as they possibly can as fast as they can. But a bad guy just has to find one, and it's much faster to find the first high severity issue by hand. We actually do races in the office to find the first high severity issue on a target site, and none of us use scanners, tools, or proxies. We use our browser. Any other questions? All right, thank you all very much for your time. I hope you liked the presentation.
able to catch the end, but it was good. So.
Thank you, appreciate it.